Sekejap dah tuan ni.
Okay.
Lama tak ada tuan ni? Ada 1 jam, setengah jam.
Setengah, tak pasti ya, setengah jam kot.
Okey. Siap kita tunggu sementara kita tunggu ramai sikit.
Okay.
Saya pun baru on komputer ni, komputer saya problem pula. Tu sementara saya on ni, kita tunggu kawan-kawan kita yang lain.
Okay.
Okeylah, kita mulakanlah. Baik, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Sebelum kita mulakan majlis, kita baca mula kitab Al-Fatihah. Alhamdulillah, bersyukur kepada Allah SWT. Pada petang ini kita dapat menjalankan sesi Kolokium bulan Julai 2022. Pembentang pada petang ini Dr. Nur Syazwani Ghazali. Latar belakang pendidikan beliau telah mendapat Doktor Filosofi daripada Universiti Teknologi Malaysia tahun 2020 dan telah menjadi Japan Visiting Researcher di Hosei University, Japan tahun 2015. Mendapat Master of Science in Mathematics daripada Universiti Teknologi Malaysia tahun 2012 dan first degree Bachelor of Science Computational Mathematics with Honours tahun 2010 daripada Universiti Teknologi Mara. Tajuk pembentangan beliau pada petang ini, An Adaptive Tree-Based Multi-Channel Wireless Sensor Network. Jadi untuk mengetahui dengan lebih lanjut berkenaan pembentangan beliau, tanpa membuang masa, saya mempersilakan Dr. Syazwani untuk membuat pembentangan. Dipersilakan.
Thank you so much, Dr. Agus. Thank you everyone for being here. Today I will present on my PhD work actually. This was my PhD work. This is more on knowledge sharing. What I did during my PhD is the adaptive tree-based multi-channel wireless sensor network, and I have 3 supervisors, which is Associate Prof. Dr. Sabaria Baharun from University Technology Malaysia, Professor Dr. AKM Muzahidul Islam from UIU, University Bangladesh, Professor Dr. Koichi Wada from Hosei University in Japan. I get to do 1-year attachment in Hosei University in Japan, where together with Prof. Koichi Wada, and we developed 2 main contribution, which is first one is the protocol of the wireless sensor network, and second one is the simulator for wireless sensor network. Okay, so first I will explain about the background of the research, which is the wireless sensor network. Okay, let's take a look at the component of a sensor node. Sensor node is actually consists of radio transceiver. It has memory, it has embedded processor, sensors, and battery. Okay, so a sensor node is it has a sensor to detect all sorts of information from the nature, and it uses the sensors to transmit it as electronic to convey the message from the environment, such as the sensor is used to detect forest fire, to detect tsunami. It is also used in smart homes, smart meter, sensing seismic event, military application. Okay, so these sensors is very practical because it can use to you can just deploy these sensors in remote areas, and it can self-organize itself. However, it has several limitations, such as it has half-duplex properties, which means it can only transmit or receive message at one time. So in one time, it cannot do both. It can either transmit or receive message. It has limited computation with 8-bit and 10 megahertz. And it also has an energy issue, which it has a limited lifetime because it uses a battery. So when the battery depletes itself, so the sensor is no longer can be connected to the network. So usually these are limitations of the sensor node, and it also has a memory issue. So in order to for us to organize a sensor node, we need to address these issues regarding the limitations of the sensor node. Okay, so for example, we just deploy this sensor node. Let's say that we have many sensor nodes and we deploy it in wherever we like. Okay, so these sensors can connect to the base station. Okay, let's say this is the base station, and you deploy it anywhere. And the sensor node, what it does is it tries to connect. It tries to connect with each other, and it tries to find a way to the base station to relay the message, to relay the information that it gathered around the area. Okay, so for example, it detects tsunami, or detects wave, or detects movement. For example, in military application, so it tries to send the message.
Sorry, Dr. Syazwani, I think your slide is not moving. Sekarang baru slide 1.
Sorry. Lemak sini. Oh, okay. Sini nampak? Can you see the second slide?
Yes, now we are on the second slide.
Okay. So actually, I've already finished this slide, so can we move the research background? Okay. So as I said just now, if we deploy these sensors to wherever we like, so these nodes are trying to send this message to the base station by transmitting it to the nearest nodes. Okay, so we need to have a structure so that the nodes, the message goes to the base station. For example, if the node doesn't know where it needs to send this message, it may send to these nodes or this node. So the message isn't going anywhere, and the base station cannot collect the information that is required. So the sending of message from to the neighboring node is called hopping, or when it requires more than one hop, we call it multi-hop. Data converge casting means the data is converged to one base station. Okay, so the middle nodes acts as a transitional nodes. Okay, so this is we call this is a flat network because it still does not have any structure. And when we try to make it a structure, make the structure out of this sensor nodes, it can be many architecture. One of it is tree-based. Okay, so the tree-based network has a tree structure where it has leaf nodes at the end of the network end of the network tree, and the middle one is the transitional nodes. Okay, so
sorry, Dr. Syazwani, again we are still on
really?
slide number 2.
Exactly, the slide is not working.
Oh, yeah.
Yeah, thank you.
Saya buat macam ni je lah, boleh? Okay. So when the nodes are having a structure like this, it is called tree-based network. And what happened in the tree-based network, it's still not. It is a good structure. However, some other issues may arise if we use a single channel. Sometimes we use a tree base or cluster base. Okay, so we clustered the network and we tried to connect it to the base station. It is more proper and reliable architecture than the flat network. So the one in the middle, when the transitional node, something happened to the transitional nodes. For example, it depletes its energy or it's having a failure. So all the leaf node doesn't know where to go. Okay, so we need to address the maintenance issue. And one more issue is because if it is a single channel, then the intra-channel interference is high. Okay, so as we know just now, the sensor node has half-duplex properties where it can only transmit or receive message at one time. So the nodes needs to be at the same channel. However, it cannot have high number of intra-channel interference for it to send or receive message because of the interference that might happen. Okay, so we need to address this issue. Okay, so the solution for this issue is to apply multi-channel to the network. Okay, so there are three types of channel assignment, where you can have a static channel assignment, you can have semi-dynamic or dynamic channel assignment. Okay, so in existing literature, there is a static channel assignment, dynamic and semi-dynamic. But after we do the literature review, we found that in semi-dynamic and dynamic channel assignment, there are reliability and network connectivity issue. It requires frequent channel switching, that causes to consume energy and risk of deafness problem. And it also arises the global synchronization error. And for the static channel assignment, it is not adaptive to current requirement, and node leaf and maintenance issues are neglected. Okay, so from these issues, we come up with a big question on how to build multi-channel wireless sensor network protocol while ensuring connectivity and adaptivity to changing requirements. Okay, so this is our big question that we need to solve. So the scope of this research is assumed to have single half duplex transceiver, and for the protocol, only one single sink in the network. For the simulator, we consider independent relationship between power, transmission range, and interference model. Okay, this is the literature review. Okay, so Wu and others propose a tree-based multi-channel, which is a static channel assignment, and these 4 papers focus on the distributed channel assignment. It uses reinforcement learning, load adaptive learning-based scheduling, and mobile agent-based architecture. So the limitation for the tree-based is no solution for node joining and leaving, and in all these papers, the maintenance issues are not addressed. So we try to address the maintenance issue, and this is the analysis that we made. So for channel assignment method, if we use a centralized channel assignment method, centralized means the base station will assign the channel assignment for the whole network. It is easier to set up because of simplistic application, and it has lower computational complexity. However, it is not suitable for maintenance because required a lot of calculation on controlling node, and the sharing information through all nodes is in its routing tree, which is high communication cost in multi-hop wireless sensor network. Okay, so imagine a very large wireless sensor network. So if the information needed to coordinate a centralized channel assignment is very costly in terms of energy. So we have another channel assignment method, which is the distributed channel assignment, where the decisions are based or done locally or node based. Okay, so the decision of assigning channel depends on the node itself. Okay, so we can either use centralized or distributed. Okay, so here we lay out the advantages and disadvantages of centralized and distributed. So the distributed, it requires small memory, and it involves nodes, small neighborhood, and results in scalability. However, it needs detailed time synchronization for the sending and receiving message is at a sync lah. No specific control center, frequent channel switching, which cause the switching delay and scheduling overhead, and slow to converge to optimal solution and have higher computational complexity. Okay, so we try to extract the advantages and the advantages of centralized and distributed. Okay, so we try to extract both. So we come up with semi-dynamic channel assignment method. Okay, so based on this literature, centralized ensure connectivity, but it's not suitable for fault tolerance and maintenance solution. Distributed is more suitable for maintenance, but it requires global synchronization, which causes synchronization error. So we propose a hybrid, which is centralized and distributed channel assignment scheme in 3 phases solution. Okay, but our contribution in this thesis is 2, which is the protocol and the simulator. Okay, I will explain one by one. But first, we will look at the adaptive tree-based multi-channel wireless sensor network protocol, or ATBMC. Okay, this is the network model for assignment for ATBMC, assignment method is semi-dynamic. No control channel. Construction is centralized. Maintenance is distributed. Synchronization not required. Broadcast support inside 3 branches. Channel model is orthogonal. It means there is no interference between different channel, and interference model is protocol model. Okay, this is the conceptual network where you have a large network, and we want to assign few channels. Okay, the less the channels is more desirable, and we try to reduce the number of channels to because in channel assignment usually we try to reduce the number of channel used. Okay, but we wish from this layout, any node in this network can divert its path whenever necessary. It means it can change its channel whenever necessary if it is required. Okay, so it is adaptive to the environment or changing requirement. Okay, this is the problem statement for simulator. Existing simulator may not be suitable for developing new protocol for wireless sensor network because it is usually all the existing network simulator is general network simulator. Parameters are not suitable for cross-layer wireless sensor network application, and we have large tracing file which is not necessary and not scalable for wireless sensor network because we have a number of nodes, and it is almost impossible to implement new protocol and unable to change control focus, which is centralized, has hybrid and distributed implementation. So we wish to develop new simulator and how to develop a new, and the question is how to develop a network simulator suitable for changing requirement of new protocol design for multi-channel wireless sensor network. Sebenarnya ada dia punya literature review for simulator. Maybe it is lost somewhere, but never mind. Okay, maybe we look later. Result. Okay, we look at the research framework first. So just now we discuss on the research gap on existing multi-channel wireless sensor network. Distributed control protocol may be adaptive but not stable and low reliability, slow convergence and require global synchronization, and so on. Just now we discussed, and so we need to fill the gap where we want to build a multi-channel wireless sensor network which is reliable and adaptive to situation, and to build a scalable multi-channel wireless sensor network that is adaptive to current requirement, to build a simulator that is able to simulate large wireless sensor network, and we want to build the ATBMC protocol and CHARM simulator, where ATBMC is reliable, adaptive, and scalable. The CHARM is specific for wireless sensor network, low memory usage, and so on. And we try to validate the simulator and the protocol and move to conclusion. Okay, so that is our research framework where we will look one by one. So this is ATBMC flowchart. It has 3 phases. The first phase is neighbor classification phase, and second phase is channel initialization phase. The third phase is adaptive network phase. And this is the start of the node and runs until the node depletes its energy. Okay, so the first and second phase is centralized. It means it starts at the base station, and the distributed is the decision of the channel is made locally. Okay, so in the first and second phase, the is to prepare the information needed for the channel setup of each node. And the second phase is to assign a main channel to each node. And the third phase enables the node to change channels whenever necessary. Okay, this is the first phase of neighbor discovery phase. First phase, which is the neighbor discovery phase. Okay, so let's say we have this network, and the purpose of this phase is to collect neighbor information and classify into child list and parent list to ensure shortest routing. The input is a flat network. Okay, so you have a flat network where it does not have any structure. So you try to change this flat network into, you try to gather information of neighbors in this phase. Okay, you try to find the parent's ID. So it sends message and it gathers information such as the number of hop to the base station. It identifies which are the parents' nodes and which are the children nodes. Okay, so for example, for this node, these are the parents' nodes and these are the children nodes. Okay, so it identifies all the information that is needed for it to do the channel assignment. Okay, so from this phase, we get this output. And the second phase is the channel initialization phase, where the channel initialization phase, we assign channel for each node based on the least interference for each node. Okay, so the least interference for each node is actually we use this flowchart. Okay, so when we start, the level is 1, means it is at hop 1 hop to the base station. So it will follow through lah. If the maximum level reach, okay, kita can has all nodes level have been assigned, so we assign all channel until it stops lah. So we assign channel for all the nodes. And then the third phase is the adaptive channel assignment phase. Okay, so when something happened to the node, for example, it has two conditions. One is when it has some interference where it cannot send message because it is half duplex. So when it tries to connect with the parent node and the parent node is busy because currently it is connecting with 2 other nodes, and maybe the message is sent at the same round. Okay, so this node cannot connect to the parent node, so it will try to connect with other parents, and it will change the channel temporarily. And this is the adaptive feature of this protocol. And another feature is it is fault tolerance to the requirement. Okay, so for example, this node depletes its energy, so the children node will try to connect with other parent node and send to the and connect with the base station. Okay, so that is the maintenance solution for the adaptive channel assignment phase. Okay, so this is the flowchart on how the adaptive channel assignment phase works. So starts with sending package. If it's received as acknowledgement, then sending package successfully and it stays on current channel. And if does not receive acknowledgement, so have it reached the threshold, then dia akan it will repeat itself and sending package lah. Kalau tidak, dia akan tukar the channel and connect to other available parent nodes. Okay, this is the results for packet delivery rate and packet delivery rate based on the transmission range. So kalau when the transmission this is actually for the simulated. Okay, this is the impact on the traffic density. Because this is for the simulator, I think that silap susunan. Okay, this is the impact of traffic density. We compare our protocol with existing. This is the tree-based protocol, TMCP, in our literature review, and this one is ALBS, which is the reinforcement learning. This is the distributed channel assignment. Okay, so we found that in low traffic density, the packet delivery ratio for ATBMC is the same as TMCP, which is the tree-based. And in high density, the ATBMC shows that the packet delivery ratio is significantly increased from the TMCP. And for ALBS, the ATBMC is perform much more stable than the ALBS in low traffic density, and in high traffic density it performs better, but almost similar. Okay, this is the effect on the number of nodes for the impact of number of channel using different number of nodes. So here we use 200 nodes, and here we use 400 nodes. Okay, so after 200 rounds means round is when we consider one round is one action can be taken, like it's either sending message or receiving message. Okay, so one round is like T equals to 200. Okay, so ALBS needs more round to converge to optimal solution, and all protocol require more rounds in 400 nodes because more round consumed on sending packet trials than 200 nodes. TMCP decreased as higher number of channel packet loss by intermittent nodes that depletes its energy and disconnect tree branches. Minimal computation required for TMCP cause higher packet delivery rates than ALBS. Okay. So here the ATBMC shows a better performance in 400 nodes and in 200 nodes. Because when there are 400 nodes, the energy use is much greater than 200 nodes because there's a lot more of intra-channel interference. So it shows that ATBMC perform better in a busy network after 200 rounds. Okay. So next is the energy consumption, network connectivity, and network lifetime. So this graph shows the number of rounds versus the number of nodes. So when the number of nodes is higher, so the ATBMC is the blue one. Okay, so number of rounds beginning of the experiment until the moment where 10% of the nodes deplete its energy is used to measure the network lifetime. Okay, so this is the number of rounds that can be achieved until 10% of the nodes depletes its energy. So in most cases, the ETBMC perform better than TMCP and ALBS. So as a conclusion, the problems that from the problem statement we contribute by we have reliable and network connectivity issue to a reliable and connected multi-channel network structure, and we have neglected maintenance issue. We have successfully set up and maintain an adaptive multi-channel network. We reduce the energy costs and we eliminate the use of scheduling in adaptive protocol. Okay, so that is our contribution for the protocol, and CHAM is converged casting hybrid control architecture for multi-channel web sensor network application or simulator. Okay, so CHAM is this is previous network simulator, and S2 and S3 TOSIM, OMNET++, and JSIM. All of these wireless, network simulators simulate general network where it has large tracing file, energy constrained environment is not considered, it has inherent design which is difficult to implement, a new protocol is not scalable until unable to simulate more than 100 nodes, and complex channel assignment in wireless sensor network is not considered. So that's why we decide to develop a new simulator specifically for wireless sensor network. And the simulator features, it has visual node scatter and data converged casting process, consider collision and energy constrained environment, display result in any parameter specification, control focus include centralized, hybrid, or distributed, provide relevant numerical, and so on. Okay, so we developed this simulator using object-oriented programming in Java. So we have class, class is the network, and we have node I, node J, and so on. And our object is the nodes and the base station. Okay, so each node has its own method. So each node is an object, because this object can has various methods that it can send message, can receive message, it can turn itself to sleep, it can change the channel. Okay, so this node has so many attributes, and also the base station can send packet and receive packet and gather the information. Okay, this is the simulation parameters where in the class or in the network we have the graph and we have the field size, number of channel, aggregation, channel trees, that is the shortest path, and so on. And these are all the attributes of the class network, and these are the attributes of the objects or the nodes. Okay, so it has ID, it has channel, it has main path, it has IDs, number of neighbors, and so on. Okay, so it has energy, list of failure of parents, and all of these are required in order to do our adaptive multi-channel assignment. Okay, so this is the layout for CHAM. Okay, we can use our own coordinate, or we can assign the simulator to randomly assign coordinates. Okay, so we just write the number of nodes. Let's say we choose new random coordinates, and then we just enter how many nodes that we want. Okay, so I've tried up to 100. I tried up to 1,000 nodes, and it can run and it has no problem. And we can specify the transmission range. Okay, so to be in meters. For example, you put 100 meter. It means the nodes. The transmission range is 100 meters. So in 100 meter, the node can connect with each other. So it is neighboring to each other. the field size is how big is the network size that you want, because it will generate these nodes based on the field size. So we have a number of channel, and we have maximum number of neighbors that it could have. So this one is for the intra-channel interference. So we have the channels that that we want to assign for this network. Okay, so this is the real output from this. Okay, so it has generate random nodes in range, intra-channel interference, and so on. So it has this one in range, intra-interference, number of hop, channel. Okay, so when you click each of this button, it will generate all the information here lah. Okay, so we can customize each of the button, because this is in Java. So this is an open source. So I think it's very flexible, so that the developer, or when you want to implement a new protocol, you can just change the function for the button that you want from here. Okay, so so this is one of the result sheet. Okay, it has several result sheet, and this is the main one. That this is the summary for the information that is currently what is happening in the nodes. So let's say we generate 219. Let's say we generate no information on the number of nodes. Okay, so we generate the nodes. Okay, so the ID of the nodes is stated here. This is the status of the nodes. Again, this is S is for sending lah, for the main, the node I. Okay, node I to node J. So it has the action, what it does. Okay, so from free, it is changed its status to sending. Okay, and then it will tell you if the energy of the node, and what is the current round, success, whether it's success or fail. So S is for success, and whether it needs to change path or no, and change to what the path is changing to, which ID again, which node, and the new channel that is assigned for each node, and number of available parents. So you can sometimes it has other option for the parent. Okay, so this is the summary for current round. So this is round 1. So this is the summary for current 1. So this will be generated for until all the nodes depletes its energy. So depending on the number of nodes that you choose, and the energy. Okay, so number of packet transferred to the base station in this round 8, and so on. All the information is listed here, and these are the usability feature for the simulator. And this is the specification of charm, and it is it can be run in Linux, Mac OS, and Windows. And the charm contribution is successfully simulate large network energy and it can simulate data converging process for multi-channel wireless sensor network for charm lah. Okay, so these are the contribution for charm. Okay, these are the references, and this is my list of publications. I think that's all from me. Thank you so much.
Okay, terima kasih Dr. Nur Syazwani. Okay, sekarang sesi soal jawab. Saya buka untuk para pensyarah bertanya soalan atau mohon pencerahan, dipersilakan. bidang ni macam communication and satellite dalam engineering, betul lah Dr. Syazwani?
Dia lebih pada network, macam lah network kan. Network, because I was attached in lab dekat MJIT. We follow Japanese style laboratory where every week everyone needs to present, and we are in the communication and CSN, communication and system network research lab. So everyone in the lab needs to do research based on what the lab is doing. So that is the communication and system lab. So this is what I did there lah. Any question?
Okay, any question from the floor, please?
Assalamualaikum. Thank you for a very impressive presentation. Just want to, based on the idea that you share with me, is that your study is related to the micro and the smart grid application?
Smart, because these are sensors, I think it can be applied to many smart homes, smart meter, and I think maybe it is related, or maybe it can be application into that area also lah.
Oh, okay. All right. Thank you.
Welcome.
Any more question, please?
Selamat petang.
Selamat
Yeah,
petang.
petang, Prof.
This research is related to computer science.
Yes.
It's not mathematics, right?
Not mathematics.
Oh, so no any area of mathematics is involved.
Because I think I wish to later to prove this using mathematics also, because
Prove what?
Most
Prove
of
what you are going to prove?
I mean using graph coloring, because this is like graph coloring, right? So I think it is interesting if we can show the improvement using mathematical model instead of simulator only.
I see. So some graph coloring
Graph
method you are going to use, then improve. You want to improve this by using mathematics.
Yeah.
Okay, good.
You think it can be done?
All right, thank you.
Yeah, any more question, Prof?
Yeah, it is a bit far away from my research area, so that's why it's very difficult. But it's okay if Dr. Syazwani wants to apply some mathematics methods here, that it should be encouraged.
Yeah.
So I guess we can see in future some result which is more and less closely related to mathematics, and maybe next your talks, your results will be related to mathematics, inshallah.
So, Prof.
All right. Good luck.
Okay, any more question? Ada soalan lain, Pak? Kalau ada, boleh tanya, kita ada masa lagi. Okay, mungkin semua sibuk marking kan ya. Okay, jaga kalau tiada apa-apa isu dibangkitkan, kita tangguhkan Kolokium kali ini dengan surah Al-As dan tasbih kafarah.